Hello my precious friends, I really hope that you are doing great. Welcome to our today's class. It's our fourth lesson on a given form 3 mathematics topic called sequences and series. So we are looking at our fifth example, which is a past Kcse question tested in 2001, paper 2, question number 19. So it reads that the nth term of a sequence is given by 2n plus 3. So part A of the question, we are told to write down the first four terms of this particular sequence. So in part A of the question, we are told that the nth term is given by the equation 2n, then of course plus 3. Then they want us to write the first four terms of this particular sequence. Therefore, the first term will be equivalent to, remember, if you are given nth term as 2n plus 3, it simply means that n represents the number of terms. Therefore, our first term will be, we'll just have 2 into the first term, therefore n will be 1, then of course plus 3. So this one will give us 2, so this will be 2 plus 3, which of course is going to give us a positive 5. Therefore, this is the first term of this particular sequence. Then the second term will be given by, so we have 2 into n, of course, is represented by 2. So the second term, n will be 2, then of course plus 3, which will give us 2 by 2. I'm going to get 4, then plus 3, which is going to give me 7. Therefore, the second term is 7. Remember, we are required to state the first four terms. Therefore, the third term will be given by, so we are going to have 2 into n. So the n will be 3, then of course plus 3, which is going to give us 2 by 3. We are going to get 6, then of course plus 3, which is going to give us a positive 9. And therefore, the fourth term will be given by, so we'll have 2 into 4, then of course plus 3, which is going to give us 2 by 4, we'll get 8. Then of course 8 plus 3, we are going to get a positive 11. Therefore, these are the first four terms of this particular progression. Then we also need to identify the type of the progression, whether it is an AP or a GP. We said that for the case of an AP, they are defined by what we call, that is the common difference. Whereas for the case of GP, they are defined by what we call a common ratio. So in part A, we were told to write down the first four terms of the sequence. Therefore, the terms of the sequence are, the first term, we found it as 5. Therefore, the first four terms will be 5, comma. The second term is 7. Then the third term, we got it as 9. Then, of course, the last term or the fourth term is actually 11. Therefore, these are the first four terms of this particular sequence. So clearly you can see it is an arithmetic sequence, because the common difference will be 2. Similarly, 7 minus, that is 9 minus 7, you'll get 2. Similarly, 11, that minus 9, you're going to get 2. Therefore, the common difference of this particular progression is actually 2, and therefore we are dealing with an arithmetic, that is progression. Then we move to part B of the question. So in part B of the question, we are asked to find S50. That is the sum of the first 50 terms of this particular sequence. Now that we have identified that it is an AP, because we have seen that it has a common difference, which of course we have found it as to be 2, then we know that the number of terms for any arithmetic progression, that is the sum of terms, is given by n over 2. Then into bracket, we usually have 2a, then of course plus n minus 1. Then you multiply with d, then of course you close the bracket. It means that S50 that we are required to find will be given by the following. So the number of terms will be 50, then divided by 2, then into bracket 2 multiplied by a. Remember, a usually represents the first term, and we can clearly see that our first term is 5. Therefore, I'll substitute with the first term, which is 5, then plus the number of terms is 50, then minus 1, then we multiply with the common difference. Clearly the common difference is 2, so multiplied by 2, then I'm going to close my bracket. So this will give me 50 divided by 2, I'm going to get 25, then into bracket 2 multiplied by 5, I'm going to get positive 10, then of course plus 50 minus 1, I'm going to get 49, then of course multiplied by 2. So this one is going to give me 25, then into bracket this will give me 10, then plus. If you take 49 multiplied by 2, you're going to get 98. So this will be I'm going to get 98 here, then I'll close my bracket. So this one is going to give me, we can feed this one directly on the calculator, because 10 plus 98, you are going to get what we call that is 108. So we are going to have 25, then into bracket 10 plus 98, you get 108. Therefore it means that let me separate my working using this particular line here. So this one simply means that our value of S50 will be given by the following. Therefore S50, or the sum of the first 50 terms, will be given by, if I take 25, so 25 multiplied by 108, I'm going to get 30, 20. So this one is 25. 25 multiplied by 108, I'm going to get 2700. So this one is giving me 2700 as the sum of the first 50 terms. Then we are going to move to part C of the question. So in part C we are told that show that the sum of the first n terms of this particular sequence is given by Sn is equals to n squared plus 4n. So because this is an AP, and we know that for the AP the sum of n terms, that is Sn, is given by n over 2, then into bracket 2a, then of course plus n minus 1, then close bracket, you multiply with d. So if I substitute my values here, we are required to find to show that Sn is given by this equation. Therefore Sn will be given by n over 2, then into bracket 2 multiplied by, the first term of this particular progression was actually 5, so this will be my a is 5, then of course plus n minus 1, then we multiply with the common difference. The common difference of this progression was positive 2, so we multiplied by 2, then we close the bracket. So Sn will be equivalent to n over 2, then into bracket 2 multiplied by 5, I'm going to get positive 10, then plus 2 multiplied by n, I'm going to get positive 2n, then 2 multiplied by negative 1, I'm going to get negative 2. Then I'll close my brackets. So this will give me n over 2, then into bracket, I'm going to get 10 minus 2, I'm simply collecting the like terms, then of course plus 2n, then I close the bracket. So this will be equivalent to n over 2, then into bracket. So this will give me 10 minus 2, I'm going to get positive 8, then of course plus 2n. Then I close my bracket. So let me erase the first part here. So if I proceed with my working, I'm going to get my Sn being equal to, so Sn will be equivalent to, if I open the brackets, I'm going to have n over 2 multiplied by 8, then of course plus n over 2 multiplied by 2n, multiplied by 2n. So of course 2 here, 1, 2 into 8, that is 4 times. Therefore it means that Sn will be equivalent to n multiplied by 4, I'm going to get 4n, then of course plus 2 and 2 will cancel out, n times n, I'm going to get n squared. Therefore if I rearrange, I'm going to have Sn being equal to n squared, then of course plus 4n, which was actually the equation that I was given here. So we have showed that Sn is equals to n squared plus 4n. So the second part of part C, we are told to hence or otherwise. If you are given the word hence, it simply means that you have to use one of the answers that you got in the previous stages. But if you are told otherwise, it means you are free to use any other applicable method that will still give you the same final answer. So hence or otherwise, find the largest integral value of n such that Sn will be less than 725. So we are told that such that Sn will be less than 725. So in order for us to solve this, it simply means that we are going to rewrite our equation in this particular manner. So where I have Sn, I'm going to substitute with 725. So I'm being told that the value of Sn must be less than 725. Therefore, I can substitute 725 actually being, so the 725 is actually greater than Sn. So let me rewrite it in this particular manner. So we had this equation here. We have Sn is equals to n squared, then plus 4n. Remember, I can rewrite this one as n squared plus 4n is actually equal to Sn. Now, from this particular stage, I want to substitute the values that I have here. So let me substitute my values. So I'm going to get my equation to be given by the following. So the equation will be, so if I substitute, I want to substitute this one here for this particular equation. So I'm going to end up with n squared. So I'll have n squared plus 4n. So this one will be, so remember Sn is less than. My Sn is less than. Therefore, this is my value of Sn. So the equation will be this particular value of Sn is less than 725. So Sn is less than 725. So I want to solve for n. So for me to achieve that, I'll replace this one with an equal sign. So let me replace this one with an equal sign so that I can easily work out. So I'll assume it is n squared plus 4n is equals to 725. Therefore, this one can be written as n squared plus 4n, then minus 725 is equals to 0. So I substituted with equal sign so that I can solve for the value of n. Then, of course, I'll just replace back. So this is a quadratic equation. Therefore, in the form ax squared, then plus bx, then, of course, plus c is equals to 0. So clearly you can see that the coefficient of n squared is 1. Therefore, my value of a is 1. My value of b is, the b is 4. Then the value of c is actually negative 725. So c is negative 725. Then b is actually positive 4. Then the value of a is the coefficient of n squared, which of course is positive 1. So the formula requires that, let me also erase this area so that we can use it. So the formula, the quadratic formula requires that our value of n to be given by, so we'll have the value of n being given by negative b plus or minus the square root of b squared. So b squared minus 4ac, then this one, then the whole thing divided by 2a. Therefore, my value of n will be given by, so negative b, I'll have negative 4. So negative 4 plus or minus square root of b squared. So my value of b is positive 4. So this is 4 squared, then minus 4 multiplied by a is 1. Then times c is negative 725. Then the whole thing is divided by 2a. So the value of a is actually 1. So this will give me negative 4 plus or minus the square root of, I'll feed what is under the root on my calculator. So I'm having 4 squared, then minus 4 multiplied by 1 multiplied by negative 725. So this one will give me 2916. So this is 2916. then divided by 2 multiplied by 1 will just get 2. So this will be negative 4 plus or minus the square root of 7, that is 29, 16 will be positive 54. So the square root is 54, then of course divided by 2. So it means either our value of n will be negative 4 plus 54, then divided by 2, which is going to give us, so let me feed on my calculator, open bracket, negative 4, then plus 54, then I close the bracket, divided by 2. I'm going to get my answer as 25. So the value of n is 25, or the other possible value of n will be negative 4 minus 54, then divided by 2. So this one will give me the answer as, so I'll have open bracket, negative 4 minus 54, then I close the bracket, then divided by 2, the answer will be negative 29. So I'm getting negative 29. So I'm getting two possible values of n. Okay, so let's see which value will be the most appropriate according to our working. So let me erase this part so that we can use it for to compute the remaining part of the question. So we are going to end up with the following. So we are getting two values of n. N is 25 or negative 29. But the question was asking us to find the largest integral value of n. Remember, an integer is either a positive or a negative whole number. So the largest integral value, of course, between 25 and negative 29, the largest value is 25. Therefore, we are going to work with 25. So we'll say that, therefore, the value of n will be equal to 25. I've chosen 25 because the question is strictly wanting the largest value of n. And between 25 and negative 29, 25 is the largest value of n. So we are asked to give the largest value of n such that Sn will actually be greater than 725. Remember, we had this particular equation here. We had n squared plus 4n being less than 725. So we have solved this equation and we found that the value of n is 25. So it means that if you substitute 25 here, so this will be 25 squared plus 4 into 25, then it should be less than 725. So this one will give you, if I take 25 squared, then plus 4 multiplied by 25, I'm going to get, that is 25 squared, then plus 4 multiplied by 25, I'm going to get 725. So if you substitute the value of n being 25, you'll get that 725. So you'll get 725 being less than 725. So remember the value of n that we have gotten here, we were assuming that this one is equal to 725. Therefore, the question wants the value of n such that Sn, the value of Sn is less than 725. So of course, the possible value will just be when we pick n being 24. So the value of n that will give us the value of Sn being less than 725 is n being equal to 24. And we can actually try to prove this and see whether it is true. So let's try to just prove this and see whether what we are picking at 24, is it actually a true value. So remember, we had n squared plus 4n is less than 725. So if we work with n being 24, we'll have 24 squared, then plus 4 into 24 being less than 725. Let's see whether this one is true. So if we take 24 squared, then plus 24, if we pick 24 squared, then we add 4 multiplied by 24, we are going to get the answer as 672. 24 squared plus 4 times 24, you'll get 672. So you see 672 is indeed, it is true. It is less than 725. Therefore, the value of n that will give us as an Sn which is less than 725, the value of n will actually be 24. Because remember, 25 is giving us a value of Sn which is equal to 725. Therefore, a value that will be less than 725, we must pick our value of n being 24. Therefore, the value of n, integral value of n such that Sn is less than 725, it will be 24. Thank you very much for accompanying me until the end of this particular lesson. I do not take it for granted. In case you are new to the channel, kindly hit the subscription button and also turn on the notification bell so that whenever I upload a new video, you'll get notified. Until next time, this is Kind Tuition Academy.